going to do the application of what we've been doing with derivatives. So, velocity and other rates of change. Here's a typical graph of movement of an object. Have you ever seen S of t before, physics people?
Or D, but since we're using D.
Yeah, D for displacement. Well, we use S of t for position or displacement. T is the time. So if the slope of a function is the change in position over the change in time, this rate of change will be the average velocity in kilometers per hour. Delta S over delta T. That's the slope of a secant line, which is the average rate of change. Yeah. The speedometer in a car does not measure average velocity. What does it measure? Instantaneous velocity. So the definition of instantaneous velocity is the derivative of the position S equals f of t with respect to time. So you notice all of this formula is here. So basically the thing you need to get from this is velocity is the derivative of position, right? So velocity is the what derivative? First derivative. Acceleration. Acceleration is the second derivative, is the derivative of velocity. It's the second derivative of distance. Is the derivative of the velocity. So I'll repeat. The velocity was the derivative of distance or position. Acceleration is the derivative of velocity. So that means acceleration is the second derivative of position. I found it twice. So acceleration is the first derivative of velocity and the second derivative of position. Guess what the third derivative is? A jerk, yes. A sudden change in acceleration is called a jerk. When a ride in a car or a bus is jerky, it's not that the acceleration involved are necessarily large, but that the changes in acceleration are abrupt. A jerk is what spills your soft drink. So, here's a summary of what you need to know. Velocity is the first derivative of position. Acceleration is the first derivative of velocity or the second derivative of position. And jerk is the first derivative of acceleration, second derivative of velocity, or third derivative of position. Velocity to the right or up is considered positive. Does that make sense? While velocity to the left or down is to be considered negative. And here's something for all you physics people. Speed is the absolute value of velocity. So velocity can be negative or positive. However, speed is always going to be positive. Okay. Example 1, the position of an object can be expressed by the function s of t equals 3t squared minus 9t plus 5, where t is in seconds and s is in meters. Find the position of the object at t equals 5 seconds. Does everybody understand? S of t is the position. if I want to know the position at 5 seconds, what am I going to do? No, you would not find the derivative. What would the derivative tell you? It would tell you the velocity, right? So if I want the position at 5 seconds, I'm finding s of 5, which would be 3 times 5 squared minus 9 times 5 plus 5. So 25 times 3 is what? 75 minus 45 plus 5. Do you get 35? And what's the units there? Meters. Okay, find v of t. How do I find v of t? That is the first derivative of position. So who can tell me what the derivative of position is? 6t minus 9. Does everybody get 6t minus 9? Okay, so now if I want to find the velocity at 7 seconds, I'm going to be finding v of 7. So that would be 6 times 7 minus 9, which is 42 minus 9, which is 33. Yes? And what is that going to be? Meters per second. Now I need to find the speed at t equals 1 second. Speed is the absolute value of velocity, so I need to find the velocity at 1 second. So what's the velocity at 1 second? 6 minus 9. Does everybody know where I'm getting this from? I'm plugging it into the velocity formula, 6 minus 9. So then I get minus 3. So then what's the speed going to be? The speed is the absolute value of the velocity, so it's going to be 3 meters per second. It's not going to be negative. Is everybody good so far? Find the expression for the object's acceleration. So acceleration is the first derivative of velocity, or the second derivative of position. So what would a of t be equal to then? It would just mean it's 6, because remember it was 6t minus 9, so it would just be 6. So what does that mean? If there's no function for acceleration, that means it is? No, it's always 6, right? It's a constant. So what would the acceleration be at t equals 10 seconds then? It's going to be 6, right? Does anybody know what the units are for acceleration? Yes, it's meters per second squared. Okay, if velocity and acceleration are both positive or both negative, then a body is speeding up. You should put this on your little cards as well. So if velocity is positive and acceleration is positive, you are speeding up. If velocity is negative and your acceleration is negative, you're also speeding up. If velocity and acceleration are opposite in sign, then the body is slowing down. So for instance, if the velocity is positive and your acceleration is negative, you're slowing down. If your velocity is negative and your acceleration is positive, you're still slowing down. So they like giving you a graph like this to see if you can analyze what's going on here. So I'm going to give you a second and do this in pencil because I'm sure there's going to be some mistakes. I want you to tell me where the object is moving forward, moving backwards, where it's accelerating, etc. Okay, what would I be looking for if I'm moving forward? Yes, so what would the interval be for positive? Not 1 to 5. 0 to 5. What about moving backward? Yeah, 5 to 10. Okay, acceleration is positive. That would be, what am I looking for on the graph? Positive slope. So that would be 0 to 2 and 9 to 10. Does everybody understand that? What about negative acceleration? That would be negative slope, right? So that would be 4 to 5 and 5 to 7. So the question is, at 5, you can't find the slope at 5, so you can't include it there, right? Okay, 0 slope. 0 slope. That's where you have the flat part, right? So 2 to 4 and 7 to 9. Okay, I am going to just pause this and have the graph there to answer the other questions, because otherwise I can't see the graph here. When is an object speeding up? When the velocity is positive and the acceleration is positive. So we're looking for positive and positive slope. So that would be right here 0 to 2, 0 to 2, and there's no other positive velocity. So let's look at, well, there is here, but then it's a negative. So that would be what? What would be happening right here? So that would be slowing down because it's a negative slope but positive velocity. So that would be 4 to 5. Yes? And then let's look when the velocity is negative. And what slope is this? That would be negative. So negative, negative makes a speeding up. So that is 5 to what, 7? Yeah? 5 to 7. And then this is not negative or positive. So now I have positive slope but negative velocity. So this part right here would be slowing down. How did we do there? When does the particle have its greatest speed? The greatest speed.
Probably when it's between 2 and 4.
What am I supposed to be looking for greatest speed? But it's absolute value though, so sometimes they'll trick you and have a negative velocity, but it's absolute value, right? So absolute value of velocity. So that would be right here, yes? So that would be 2 to 4? Did you get that? 2 to 4? Very good. Okay, moving on. A softball is launched from Earth. The position S of t of the ball is given by the curve that. These are typical physics questions. Okay. So determine the height after 8 seconds. So what do I do here? Just plug in S of 8. Yes? This would be on the calculator part of the test. Yes? So I get, did anybody get an answer here? Not yet? You can punch this into your calculator. How come we don't have our calculators out? Let's punch it in and get an answer. Did you get 666.4? And what units would that be?
Yes, I did.
What units would that be? Meters. Okay, determine the height of the ball after 17 seconds. So what do I find there? S of 17. So negative 4.9. And that would be 17 squared plus 122.5 times 17. So what do we get there? What about guys at the back that were way ahead? What did you get there? The same number again? That's what I got. 666.4, and that would be meters again? Yes? Determine the velocity of the ball after 8 seconds. So what do I have to do here first? Yes, this is a parabola that's upside down, so does that make sense? What that would look like, the root? Okay, so velocity, what would I have to do first? I need to find the derivative of the position. So that would be negative 9.8 t plus 122.5. Does that ring a bell, the negative 9.8? What is that? It is gravity. Oh. Okay, so now I need to find at 8 seconds. So V of 8. So that would be negative 9.8 times 8 plus 122.5. So what do you get there? Anybody? What'd you get? It is 40 something. 44.1 meters per second. Does everybody know velocity is meters per second? Okay, determine the velocity at 17 seconds. Let's guess here. Is it going to be the same?
Negative.
Oh, it's going to be negative. Okay, so now we're going to find V of 17. So that's negative 9.8 times 17 plus 122.5. Yes, you do get the same number, but it's negative 44.1 meters per second. So what does that mean?
But it's going down.
It's coming back down? And what's happening when it's coming back down?
Accelerating.
Yeah. Okay. So determine the acceleration of the ball after 4 seconds. What do we have to do to find A? You have to find another derivative. So that's going to be V prime of t. So what do I get there? Negative 9.8. Does that make sense to you that you would get negative 9.8? That's gravity. That's the only thing that's affecting it, right? Okay, so after 4 seconds, negative 9.8. What's the units for that, by the way? Meters per second squared. Okay, next question is an area of a circle. Formula is A equals pi r squared. Makes sense? Find the instantaneous rate of change in the area with respect to the radius. So what am I actually figuring out here? The first derivative, yeah. So we're actually finding dA dr, which some people don't realize is you're finding the derivative of area with respect to the radius, right? So what do we get?
Ball.
Huh? What do you get? 2 pi r. Ooh, mind-blowing. What is that? That's the formula for circumference of a circle. Isn't this crazy? Find the instantaneous rate of change of the area when the radius is 4. So, A prime of 4 would be 2 times pi times 4, which is 8 pi. And what would the units be? Centimeters per centimeters. Yeah, this is kind of weird because the area is in centimeters squared and the radius in centimeters. So technically it's centimeters squared per centimeter, which is centimeters. Isn't that crazy?
How are you supposed to know that? Like, I'm gonna get a mark wrong.
Last example.
No, there's another page.
There's another page. Okay. A baseball is thrown in the air, reaching a height of h equals 20t minus 5t squared. This looks like a grade 11 pre-cal question, actually. Where t is in seconds and h is in meters. Find the velocity function. So how do we do that? The velocity function would be the derivative of the height, right? So h prime of t, so what would that be? 20 minus 10t. Yeah? When is the velocity 0? So what would I do there? Okay, so I set 0 to the velocity function, which is 20 minus 10t. So 10t equals 20, so t equals 2 seconds. Yes? When is the ball at its greatest height? That's where the slope would be 0. And so how would I figure that out? That would be the velocity is 0. Didn't we just do that? Yes. Does that make sense to you? The velocity is 0. Does everybody understand when you have a parabola, like why this is the case?
Yeah.
The velocity would be 0 at the maximum or the minimum, right? Yeah? Okay, so at 2 seconds from...
But you're not talking for like a velocity graph. You're talking about something just like it's this way.
Yeah, this, yes. Yeah, sorry, I should reiterate. So the position graph is a parabola, right? And where the velocity is 0 is where the slope is of that is 0, right? Which would be, does that make sense to you? Okay, I know the confusing part is when we have and you'll see this when you start doing some of these questions, is when you see a graph and you're supposed to be looking at the graph and the slope in your head at the same time, kind of like we did with the velocity and acceleration, right? Okay, so anyways, how long will it take to reach a velocity of 15 meters per second? So what do I do there? Plug 15 in for the via t thing, right? So 15 equals 20 minus 10t. Does everybody know what I'm doing? So minus 5 equals minus 10t. So what does t equal? A half a second? Yes? When and with what velocity does the ball hit the ground?
So it said h of t is 0.
Does everybody see it hits the ground when h of t equals 0? That's the ground, yes? What am I actually figuring out here? This is not the answer. When and with what velocity does the ball hit the ground? So So yeah, how am I going to find the seconds? Well, if h of t is 0, what do I plug in?
The parabola would hit the ground at the same height that it was launched from, wouldn't it? Or, assuming it was launched from the ground, so you just have to find velocity.
Well, so does it launch? By the way, h of t, just so you know from before, h of t is equal to 20t minus 5t squared. So does it launch from the ground? No, but look at this. Yeah. It does. Well, because it doesn't have a y-intercept, right? This is like grade 11 math now, right? Yeah. Okay, so how do I solve this? How do I solve this? Factor. So what's this factored? 5t, and we're left with 4 minus t. So that means t equals 0 and 4. Okay, so when and what velocity does it hit the ground? So it starts at the ground, and then 4 seconds later is at the ground again. But what is the velocity when the ball hits the ground?
So you find t at 4.
Well, if I find v of 0, what do I get? I'm sorry? V of 4? What's my formula for v of t? I'm just going to write that above. Yeah, 20 minus 10t. So 20 minus 10 times 4 would be 20 minus 40, which would be minus 20 meters per second. What does a negative velocity mean? Yeah. So that's the thing you got to wrap your head around, and I think physics people have an advantage on this because the negative sign means it like that I know from all the math up to this point, you've kind of like, if it's negative, then it can't happen or whatever. But we're not talking about negative time here. We're talking about the position, right? And when we're talking about vectors, you can have negative vectors, right? Yes.
Yeah.
Okay, a particle is moving back and forth on a horizontal line. Its movement is defined by the position. S of t equals t to the power 3 minus 12t squared plus 36t minus 30, where t is greater than or equal to 0. Find the velocity and acceleration function. So that's pretty easy. I'll give you a second to do that. Okay, yeah. Okay, so 3t squared. Yeah. Very good. And then acceleration, do you want to keep going? Very good. Does everybody see how we got that? Okay. When is the velocity 0? Plug 0 into what? The first function there. 0 equals 3t squared minus 24t plus 36. And how did we learn how to solve that? Probably factor. We can divide a 3 out of there to make it easier. So 0 equals t squared minus 8t plus 12. Yes? So what factors for 12? 6 and 2. T minus 6, t minus 2. So that means t equals 6 and 2 seconds. Yes. Yeah? So when I factor out, I'm actually I'm not factoring out the 3. What I'm doing is I'm using algebra and I'm dividing 3 to both sides out of there. So, yeah. Okay, during what time intervals is the velocity positive? Ooh. So this is again grade 11 pre-cal. How am I going to know when the velocity is positive or negative? And this is a quadratic. A sign diagram. So we're going to put a sign diagram. And what are we going to put on our sign diagram? 6 and 2. Shh. And I plug in numbers on the left of 2. So let's put 1. What do I get there? Negative. So that means it's positive. Yes. And what about between 2 and 6? Let's say you could put 4. So you get negative. And what about something greater than 6? We get positive. Okay, so velocity is positive
0
from... Now, okay, so that's a great question. I think somewhere in the question it actually said t is greater than or equal to 0. So technically this started at 0 there. Yes? Okay, so it's positive from 0 to 2 and 6 to, in this case, infinity, right?
for 0 we should.
Why are we putting square brackets?
For 0.
Oh, but what happens at 0 there?
Already it's velocity.
But you guys, velocity is a derivative. Can we find the derivative at the endpoint there? Okay, and honestly, a good rule of thumb is never use square brackets. Like honestly, it's always round brackets would be, yeah, for the most part. Okay, negative. What about negative? 2 to 6.